Hello everybody, my name is Jo Nettleton, it says there, so it must be true. My daughter's come with me today and she's insisted that I do the entire presentation. Ho, ho, ho. As it says there, I work for the Environment Agency. I head up the radioactive substances regulation part of the Environment Agency. And clearly what we're interested in is making sure that people with radioactive sources, whether they're universities or nuclear power plants, control those sources properly. So, festive theme, do reindeer near nuclear plants glow in the dark because they're radioactive? So, let's look for some evidence. My husband said when I looked at this photograph, maybe you could tell them that it's the reindeer's backside that's making the whole thing glow. Maybe not. I think we all do, though, know of a very famous deer, maybe not a reindeer, that does glow. Does anybody know what that is? Harry Potter's Patronus. Must be true. And one more picture of a glowing reindeer. This is clearly Rudolph. Nose glowing, but that's actually an infrared image. So, do radioactive reindeer glow in the dark? Actually, no, because radioactive things themselves don't glow in the dark. You can't hear, smell, taste, sniff, anything, radiation. But what does happen, and this is why people sometimes think that radioactive materials glow, is that when some materials are exposed to radiation, they luminesce, and that's called radioluminescence. So when the radiation interacts with the material, it jiggles around the electrons. Those of you doing physics will know this very well. And as the electrons settle back down to their normal energy state, they emit light. And actually, this is a really important feature that's used in a wide range of areas. So, for example, up there, this exit sign, it's a fire exit, and what we've got in there is tritium, which is a radioactive form of hydrogen, and a material that glows when the tritium radiation interacts with it. So it doesn't need any battery, won't wear out. The half-life of tritium will last for a long time. You're going to see that in a fire. I think that's good. And also, actually, the Northern Lights, the reindeer's backside, that's actually a similar sort of process, whereas in this case, the charged particles, like radiation, but from the sun, are interacting with atoms in the upper atmosphere, and the same sort of thing jiggles the electrons around in the atoms, and as they normalise back down to their normal energy state, they emit light. And the reason that it tends to be green, the aurora, is because a lot of the atoms in the atmosphere are nitrogen, and the type of light that nitrogen emits is green. Okay, so that's one reason that materials near radioactive particles might glow. There is an even more impressive reason why sometimes people think radioactive materials glow, and this is Cherenkov radiation. And this is really quite impressive physics. So any of you doing physics at the moment at school, talking to the school kids, if you're a bit bored with physics, rolling things down slopes and measuring bits of string, keep with it, because physics is fascinating. And what we've got here, you can see that we've got, I need a pointer down here, but we've not got one. We've got two situations where you've got really radioactive sources sat underwater. The top one is actually fuel elements from a nuclear reactor, and the bottom one is really high activity sources that are used to sterilize things like medical equipment. They kill the cells, they're so radioactive, kill bacteria on the equipment. Now the reason that the water looks blue is because when the radioactive particles, the charged particles from the radioactive material, travel through water, they can actually travel faster than light in water. Now all of you doing physics will know that light in a vacuum travels faster than anything. Nothing can approach the speed of light. But actually, when light travels through water, it slows down a bit. And in that situation, really fast charged particles from radioactive materials can go faster. And that causes a bow wave of light behind the charged particle to appear. So it looks blue like that. Again, radioactive material itself is not glowing, but it looks like it is. So, no, even if they're radioactive, the reindeer are not really going to glow in the dark. Second thing then, Actually, reindeer aren't very radioactive. And if they are radioactive, it's not because of the nuclear plant that they live near. And that's because in the UK, we have got incredible amount of regulation of nuclear power, nuclear plants, and you'd want that, wouldn't you, really? So we make sure the operators using those plants, the operators running those plants, do it safely, both in terms of the environment, public safety. We don't want it to go bang, do we? I don't, you might not. And we don't want them to emit things into the atmosphere. And also the workers there, we make sure that the operators look after their workers. So they're heavily regulated and the people running the plants know what they're doing for all the way that the plants are run, whether it's in normal operation, any radioactive waste is dealt with properly. If there are emergencies, you would not believe the amount of training and preparing that goes on for dealing with emergencies. When the plant comes to the end of its life, it's cleaned up and decommissioned properly, and anything transported to or from the plant is dealt with accordingly. So, pretty sure that the reindeer near the plants are safe and they're not going to be exposed to dangerous levels of radiation from the plant. Okay, so radiation doesn't make you glow in the dark. I think we still want to control it though. What does it do? So we can be exposed to radiation in two ways. If I stand next to a fire, it feels warm. The fire's irradiating me with heat. If I stand next to a radioactive source, similarly, it will irradiate me with radiation. And in fact, as part of my normal working life, I do very often go to nuclear power plants, for example. And as I'm walking around the plant, I will be exposed to radiation. I'm not worried about that. I wear a radiation dose meter that tells me what dose I'm receiving, and it's fairly safe. If I go to any areas in the plant where there might be radioactive material on the surfaces or liquids or in the air, then I wear kit, whether it's overshoes, overalls or full mask, depending on the type and amount of radiation. And that's to stop me from ingesting, inhaling, absorbing, etc. radiation, because radioactive materials are just chemicals, like any other chemicals. They're just radioactive forms of those chemicals. And if they get into your body, the cells in your body will take up the radiation. It'll take up radioactive potassium in the same way that it would take up potassium from any other, from a non-radioactive source. And once that radioactive material is inside the body, it can irradiate the cells from within. What does radiation actually do? Radiation is or creates charged particles, and they react with the chemicals. And if those chemicals are in cells in your body, and particularly if they're in the DNA in cells in your body, then there is a potential for problems. Now, I'm going to do a bit of biology. I'm not a biologist, so I'm slightly wary about that, given Linda being in the room. But we're all humans. We're all made up of cells. And in the cells, there are the nuclei. Within the nuclei of cells are the chromosomes, which contain the genetic material. And that genetic material is in the form of DNA. Okay, double helix. The ionizing radiation can actually damage the double helix, the strands of DNA in the nucleus of cells. And it can do it in a direct way. So the radiation, upon this one here, charged particles comes whizzing in and interacts with one of the chemicals in the DNA strand, causes damage, a DNA strand break. Or, a bit of chemistry, it can interact with some of the atoms in the media around the DNA. We're made up mostly of water, so there's a lot of water actually in cells, and it can split the water into charged particles themselves. These particles, H plus, OH minus, can themselves interact with the DNA atoms and damage them. So we end up with something called a DNA strand break. Damaged nucleus. And as the DNA is basically the stuff that tells the cells what to do, that might be a problem. If there is a large amount of radiation, a high radiation dose, the damage might be so bad that the cell can't repair and the cell dies. If enough cells die, we can see really quite significant radiation effects, and they can be like radiation burns, like heat burns, looks the same sort of thing, really nasty. cataracts of the eyes. And actually, if enough cells die, then we can see organ death of the organs in the body. Does anybody know who this poor chap is? Yeah. So, for those of you who don't know, he was a Russian who was poisoned by a couple of Russian spies who put a tiny drop of radioactive polonium in his tea. And that polonium was taken up into all the cells in his body and irradiated him, and the cells in his body died. And again, I just stress, the polonium didn't come from this country. It was smuggled in, so we're safe. But part of my job is making sure that radioactive sources don't get into the hands of terrorists. So it's pretty serious stuff. This actually, other than the dreadful tragedy of Alexander Litvinenko himself, contaminated large parts of London and caused problems for a few days afterwards. Smaller levels of radiation, the cell, the DNA, might repair itself. Now, it could repair itself perfectly normally. Everything's okay, everything goes back to normal. However, it might repair itself in a way that doesn't match what it's supposed to do. So it's not quite the same as before. So the cell is mutated. And there are possible outcomes of a mutated cell. When the cell reproduces, and again, I'm really wary of talking biology here, but in simple terms, when the cell reproduces, it forms replicas of itself. And those daughter cells go on to form replicas of themselves. So if a mutated cell is forming replicas of itself, you can end up, a few reproductions down the line, with a large number of cells that are mutated and doing the wrong thing. And this can lead, for example, years after the radiation exposure to things like cancer. If the cells that are affected are in a developing fetus, then when the baby is born, we can see effects in the baby, things like reduced IQ. Fairly large radiation doses cause that sort of effect. However, another thing that can happen, and really key, is potentially, if the DNA that's affected is in the germ cells, either the sperm or the ovum in mammals, then we can see genetic effects in the offspring of the individual that's irradiated. And again, it's important to say that we've not actually seen any hard evidence of that in humans yet, but we have done studies on mice, and it is an effect that's been seen in mice. So there's a lot of work making sure that we control the doses to people's reproductive organs, for obvious reasons. Okay. Having said all that and scared you all witless, it really is important to say low doses have very little risk. In fact, we are all, every one of you and me, are a bit radioactive. Some of the chemicals, some of the atoms in our body are radioactive, just as it is. We're all made up of a whole range of chemicals that have come out of stars, that from all sorts of history. And some of those atoms are radioactive. Some of the potassium in our body is radioactive. Some of the calcium in our body is radioactive. And we're all living perfectly normal lives. Bananas are really quite radioactive in comparison to everything else. What's important is that we keep doses low. And that's why we make sure that we do control how people use radioactive material. And that's whether it's nuclear power or the whole plethora of uses of radiation in medicine, teaching and research, or industry, whole set of things. So, to come back to the initial question, are reindeer near nuclear plants radioactive? Well, no, the reindeer near nuclear plants are not radioactive, at least not because of the nuclear panel. A bit like us, they're a bit radioactive. But even if they were, they wouldn't glow in the dark, but I still wouldn't eat them. Thank you.